Okay, we're going over the homework. Questions, Vicky G.
So like on the test, if we put like Zn is higher than H, or if we put instead of always CO2, we just wrote like the formula that's on our foldable, would we get points off? Like, do we have to write exactly like both rules met or like always CO2, whatever? So like you see on the
I see this. Yep.
the decomposition.
And this?
Yeah, it says always CO2 as the why or why not. What if we wrote like the combustion equation that's in our thing? Like I wrote the like an example of one of those equations.
Where?
Like in the foldable, it says CH4 plus 2O2 goes to CO2 plus 2.
So you wrote this instead of combustion? You wrote the example of the equation?
For decomposition,
For decomposition, you wrote what?
that formula instead of always CO2. Like if we say like something.
You wrote, what? I'm so confused because you're saying a lot of things. You started out talking like
Okay,
this and then.
okay, go back to single replacement. If we wrote Zn is higher than H, would we get points off? Like, would that be wrong?
No, that's right. Cn is higher than H.
That's fine.
Yeah.
Okay.
So it's not really about being right so much as about not saying the wrong why it doesn't go. So let me give you an example of the wrong why it doesn't go. So here is a double replacement that doesn't go, okay? And the reason this double replacement doesn't work is because the barium sulfate is solid. And both of the reactants must be aqueous, right? That's rule number one. Both the reactants must be aqueous. So let's say you write, I wrote down barium sulfate is a solid because that's why it doesn't go. What if I said rule number one was broken? Like this does not pass rule number one. That's fine. I know what rule number one is, right? Or both reactants are not soluble. That's good too. Or barium sulfate must be soluble. That's fine too. But what if you wrote barium is higher on the list than copper? Well, that doesn't work because the activity series is not used in a double replacement. So that is not an acceptable reason why a double replacement reaction wouldn't go, because the activity series is used in a single replacement and the solubility rules are used in the double replacement. So if you wrote this one does not go because barium is higher or because copper is higher than barium, well, that doesn't make any sense because that list is not used. You understand? So if you wrote the wrong thing, then that's a problem, okay? But there's a lot of ways to say the right thing. That's what I'm saying. Yeah, Rachel.
So for the first decomposition, like equation, one of like the like product things on our foldable. So like you put H2O plus CO2, but if your first like metal goes in there, like I don't know, since it was H2, like you obviously have to do H2O, but if it was something just like singular, would it be like something else?
Right, so let's take a look. So what if it was like something singular, like calcium?
Yeah.
Okay. So let's look. So the question is, it is H2, so there's two hydrogens there. So what if it was CaCO3? How would that decompose? Well, the foldable says ACO3 decomposes into AO plus CO2, right? So here's my A, the calcium is. So I'm going to do Ca plus 2O minus 2. So my product would be calcium oxide plus CO2. And then I would balance my equation.
But like even though,
So if I balanced my equation, 1, 2, 3, 1, and 1, it's balanced. Okay, yeah.
when you did like the plus two and like the minus two, like when you crisscross for the charges, is the only way to know like what the charge is like your periodic table or like memorizing your polyatomic elements. Like
Mm-hmm. Yep, that's how you know. Periodic, well, I mean, when you say is the only way to know, that's a pretty good way.
Well, it's just like memorizing them.
Well, how else?
I just didn't know if that's how you found it.
So you could do this. You could reverse. So there's a 1 here because there's 1 carbonate. So this goes up to plus 1, and this goes up to minus 1. And we know that carbonate is a minus 2, right? So that means that calcium's a plus 2. You can cross Chris sometimes, you know? So that's another way to do it. The best way is your periodic table and your polyatomic ions. That's the best way, is to use them enough and memorize them and be able to tell by the periodic table immediately. I mean, the periodic table is the easiest way. Plus 1, plus 2, plus 3, share, minus 3, minus 2, minus 1, full. I mean, it's a pattern. 1, 2, 3, share, 3, 2, 1. It's a pattern. Madison. Number 6. So the reason no for number 6 is because the barium sulfate is a solid, and according to your foldable, both the reactants must be aqueous. Okay? And so with the barium sulfate being a solid, that rule didn't follow. Okay, now I would like to look at the second to last one, the non-metal oxide plus water. So this is a synthesis, all right? And we know this because right here, non-metal oxide plus water, okay? Now, it's true, this could be a double replacement because it has 2 compounds. But the problem is these are non-metals. See that? Non-metals. And the double replacement is a metal, positive and a negative, positive and a negative, and this is a metal. 2 metals. See that? So that's not going to work. All right, so this is a non-metal oxide plus water. And if I open this up, it says non-metal oxide plus water gives you hydrogen crossed with the non-metal oxide, and you add 1 to that oxygen. Now, I am a rule follower, in case you haven't noticed. I like rules. What I don't like is exceptions, and I don't like it when people make exceptions for other people make exceptions for other compounds. Bothers me. I don't like it. Now, there's a joke in chemistry, and we say, I'm going to do this under the screen, so it's a little weird. We say, the book for chemistry with exceptions is this thick, right? And the book for chemistry without exceptions is this thick, right? The rules are this big, but if you add all the exceptions to the rules in, it's this big. So for those of you at home, right, the book with the exceptions is this thick, you know, and the book without the exceptions is this thick, tiny little book, right? I don't like exceptions. So I teach high school chemistry where I just teach the rules, and I teach out of this little skinny book, right? Okay? If I wanted to teach with exceptions and teach all the complications that go along with it, then I would teach college chemistry. I don't, because I don't like gray area, yeah? There's some exceptions, a few, you know, but I'll tell you, AP is doing away with the exceptions because they don't like them either. Because like it's first semester, right? So I just teach like this little teeny section. So what I do is I try and make a rule for absolutely everything. And you know that because I give you steps for everything, right? I go, okay, then step 1, then step 2, then step 3. Sometimes I feel like literally what I teach sophomores is how to follow instructions. That's like my course. What is my course about? How to follow instructions. If you follow instructions, you can get an A. And still, kids don't follow instructions. It's so frustrating to me because I say, everything you need to know, I tell you. Just follow instructions, right? Because I'm a rule follower. So what does that have to do with anything? Well, so this one here, I made up a rule to go in my foldable. The rule is you take the nonmetal oxide, you add 1 oxygen to it, you look it up in your polyatomic ion table chart, and then you crisscross it with the hydrogen. Now, does that work all the time? No, it doesn't. But you know what? I like rules. So whereas lots of honors teacher would give you plenty of them and then say, oh yeah, but that one doesn't work. I mean, you'll just have to memorize it. I don't do that. I don't give it to you unless it works. Because I want you to be able to follow instructions, to follow the rule. All right? So all the ones that I'm going to give you are going to follow that rule. See how that works? All right? I'm not going to give you one and then go, yeah, that's a little bit of an exception. No, I don't like exceptions, okay? So here it is. SO2 plus 1 oxygen gives you SO3. You look that up on your periodic table. Turns out it's sulfite minus 2. Then you add the hydrogen in front of it, and you crisscross, and you get H2SO3, which is sulfurous acid. See how that works?
What about the other O and H2O?
This one?
No, above it. Like the one you're just.
This one? Yeah. So we get H2SO3.
Yeah, but you said you added 1 O.
I only added 1 oxygen to this, and the oxygen is right here. I added it to this. See? Okay, so let's look at another one. What if it looked like this? NO2 plus water. So I add 1 oxygen to the NO2, and I get nitrate. And then I crisscross, and I get nitric acid. And then I balance. Okay, 1, 2, 3, that's correct. Oh, but I have 2 hydrogens, so I put a 2 here. Now I have 2 nitrogens, so I put a 2 there, so that's 4, and then 5. I don't know, is it balanced? It should be balanced. No, it's not balanced, so I'm going to put a 2 here and a 4 here. That should do it. I don't know. Anyway, I don't know, but then you balance it, okay? Got it? That actually might be balanced. All right, and then you balance it. So I'm only going to give you ones that work with the rule. Everybody with me? That you look up and it works. Okay? All right. So then, because of that, when you do this, you can just put the rule from the foldable in as your reason that it works, because I gave you the rule. The reason it works is because of the rule. Dangerous, though? This one doesn't work because of this rule. So it doesn't work because a positive and a positive never works. So you have to be sure that you understand when there's a positive and a positive, it never works because metal and metal never come together. So just be aware of when you're writing it works or it doesn't work because the foldable says so. So in some cases, that's acceptable. But in other cases, that's not acceptable. In all of the decompositions, you can just write always because it's a carbonate. Because all of the decompositions work. Because I said so. I'm only giving you ones that work. Okay? All right. Other questions on the worksheet? Okay, ready for the net ionic equations homework? Okay, net ionic equations homework. Here we go. Where is it? No. Okay, here it is. Okay, the first line of the problem is the one that they gave me in the problems. So my first frequently asked question is, do I have to write the states of matter? Like, do I have to write aqueous? Do I have to write aqueous? Do I have to write aqueous? The answer is yes. And the question is, why do I have to do that? And the answer is, because I said so. Because it's called a complete ionic equation. So complete it. The complete ionic equation contains states of matter, coefficients, charges, and the elements, okay? Next, do I have to write the charges? Yes. Why? The answer is because it's called a complete ionic equation. If you don't include the charges, it's just a mess. So, ionic, complete. The next one is, do I have to balance the equation? Yes, because if you don't, then when you go to cancel out these two hypochlorites, if you didn't balance the equation, you would only have one hypochlorite here. So you couldn't cancel them out. So you do have to balance the equation. All right, so basically frequently asked questions are, do I have to do any of this? The answer is no, you don't have to do any of it at all. There's a regular class right next door that you can get into today. Yes.
How many points is this going to be worth on the test?
Well, there's only one of them, but it's kind of a small order test. So maybe, let's say, I don't know, 10 out of maybe 20%.
Of the whole thing?
Yeah. Yeah, because there's like, there's not very many questions. Yeah. Maybe 15% to 20%.
Partial credit?
Right? Well, I said I'm gonna look for so many things. So I'll look for, did you cross out what are the spectator ions? If you didn't indicate them, then I won't know that you know. Does that make sense? It's gonna say the instructions will. I mean, this is a good question. So the instructions will say, write the complete ionic equation, and then I'm gonna look for, do you have all of the states of matter in there? If you don't get those points. Does that make sense? Because the complete ionic equation includes the states of matter. So if I look for that and you don't have it, you don't get those points. Does that make sense? And then the next one, it'll say, write in the spectator ions. If you get the wrong ones, then you don't get those points. So there'll be like 3 lines, right? And then it'll say, write the complete ionic, the net ionic equation. And I'll look for this. And if it's not there, then you don't get those points, right? So it's going to be broken down into steps. That's the way free responses are in AP Chemistry. So we can grade thousands of them in a short period of time. Just like AP Calculus, same way. Okay, questions? Any questions at all? Yes. Great question. So let me use a different element, okay? This is potassium. If I put potassium in water, which is first family, it will explode. Not a little bit, a huge amount, and hurt somebody. Okay, like a gigantic amount. If I put potassium ion in water, it will attach to the hydrogens and float around. These are not the same thing. This one desperately wants to get rid of its one electron. It's one of the most reactive elements on the periodic table. This one has already gotten rid of its electron, and now it's just floating around looking for somebody to hook up with. Okay? Two completely different things. Now, let's talk about H+. It was attached to this hypochlorite, but now it's just floating around. If I attach it to this, if I attach it to another hydrogen, then it's gas and it's going to float away. Because as an element, it is a gas. But as an ion, it is not. Because it is in water attached to oxygen. Not as a water particle. Sorry, I should say. Attached by the positive and negative charges. Floating around. Yeah.
Isn't a banana like made out of potassium?
Isn't what?
A banana made out of potassium.
No, one of the elements that is in banana is potassium. Banana is considered to be the most perfect food on earth because it contains so many things that your body needs.
But if you put it in water, it won't explode.
No, it just contains a little potassium bonded to other things. Okay, ions are not elements. Elements are not ions. That's why we use the word ion. That's why when we say bromine and bromide, they're two different things, right? That's why we say phosphorus and phosphide, because they're two different things. One has a charge and one doesn't. Okay? Okay. Other questions? All right, let's go to the boards.